Good morning. So this is a new mechanism and it deals with alkenes, and we're gonna see the general mechanism for an addition. In this particular case, we are looking at the addition of hydrohalic acids like HBr or HCl or even HI. But this mechanism kind of outlines how alkenes normally react. So the acids are always polarized toward the most electronegative element, which is the halogen, and the hydrogen is going to be delta plus. Now, in all these reactions, the alkene acts as a weak nucleophile and is going to attack the most electropositive element on the other molecule, which in our case is hydrogen. Now, remember, hydrogen can only form one bond, so the bond between H and Br will break. So this reaction gives two potential intermediates. It's either going to give us an intermediate where the hydrogen goes onto the carbon that has more hydrogens, so the double bond will disappear because we did use the pi electrons. So we have basically two options. In one case, the hydrogen goes onto this carbon and the other carbon becomes a carbocation, or we're going to have like the opposite. So the hydrogen can alternatively go there and we have this other type of carbocation. Plus, we have Br minus that also formed in this first step. Now, what is the difference between the two intermediates? So a carbocation is always going to be an intermediate in these reactions, but the difference between the two of them is that this is a tertiary carbocation. This one, on the other hand, is a secondary. So carbocations are intermediates where the carbon has a positive charge. The stability of carbocations is the following. We go from resonance stabilized carbocations, these are the most stable. Then we have tertiary, more stable than secondary, more stable than primary, which in turn are more stable than methyl. The next step of the reaction is dictated basically by which carbocation is more stable. In this case, the tertiary is more stable, so that is the one that is going to give us the major product where the halogen attacks that carbon. And basically is the one that gives us the major product. So the major product is going to be the so-called Markovnikov product, which practically has the hydrogen adding to the carbon that had more hydrogen to begin with, and the halogen adding to the carbon that is more substituted. This is the major product. And when you do this mechanism, you should always kind of do it this way. Pay attention to the alkene. We started with an unsymmetrical alkene, so that will always produce multiple kind of products, but this is the major.